Recording. We are building a roguelike deck builder game on Godot, and this is the second episode of the tutorial series. As always, you'll see live coding and debugging, and the process of thinking through solutions to achieve our goal. In today's episode, we're adding functionalities to our attack and defend cards, adding important game properties like health and mana, and finally finishing up our game with a playable game loop, complete with victory and game over screen. This was a very fruitful session and I had a lot of fun making this episode, so I hope you really enjoy. Second episode, start recording, sync. Action! I'm back for some more torture session, I've been calling it. I don't know, part of me kind of regret doing this a little bit because I don't, as confident as I sound and look when working on this, my head is going 1,000 miles an hour trying to figure out everything on the spot. What do I do? Do I make this decision or that decision? Because as much as I want to be like, hey, here's what it looks like live, I still want to like not fumble so much that it becomes unwatchable. So yeah, so I've been dreading this session. My hair's gotten a little longer, so you should probably be able to tell it's been a while since my last recording. So roguelike deck builder tutorial episode 2. Today, my plan is to add card functionality. So when I click on the card, it does actually something. Technically, if I want to do this in a chronological order, I kind of want to work on the deck first, but I want to do something exciting. So this is part of, it's like one important thing you should do when you're going through this huge of a project. You should make sure to work on parts that really excite you, or sometimes like be able to play through and see things happen in real life. So that way it gets you kind of excited to get going. So that's what I'm going to do. This is what it looks like. If you're curious about this, you missed the last one, you can always go back to my last episode, which I'll link up here somewhere or in the description down below. But yeah, so we can create cards. We created these cards. I made these assets, some cost. We talked about a little trigonometry. Now I know how to say it, trigonometry. This is a simple to figure out how to create this fanning effect with the card tilts. And then I made it highlight when I hover over it, and then when I click, it deletes. Now, what I want to do is, instead of cards deleting when I click, I needed to apply some sort of effect. And I think it's going to be pretty easy. So what we're going to do is we're going to create a new 2D scene. So let's call this a main. How about that? Main. Seems pretty good. I'm going to save this. So main scene will have the deck in hand, which hopefully just works. And then we're going to create a new node. And then this will be probably the game screen. So the way I do it is I always create a node first, representing a group of entities that will represent an item in the game. So we're going to definitely have some sort of like player character, right? And we're going to have some sort of enemy character that is represented by node. And this may change. But, you know, we're going to start off by organizing a scene in a way that we want to see represented. And then I'm going to decide, oh, which part of this actually share a common components, and how can we take advantage of that to make unique scene with it. So because once I have it all set up, I can always right click and say, hey, save this branch as scene, and then it'll create a scene for it, which then I can multiply. So, you know, there is a certain satisfaction of going into the game immediately with knowing exactly how you're going to divide all these components, versus this is the way that I would like to do when I'm planning. This is the planning phase of development. And each of the characters will have some sort of health, right? But before that, let's make a kind of like an exciting little sprite that represents some sort of character. So I'm going to just open up a sprite. And traditionally, 64 by 64 is a pretty decent size character, I think. I created this palette, and it's a very simple palette. I made this to make sure I restrict myself, and rest of the game has this like kind of like unison feel to it, that everything feels tied together. And you should probably do this too. You should always choose your palettes first and then try to limit what you use within the palette. Now, of course, there's an exception of like, oh, foreground should use this palette versus background so that they kind of stand together, but I'll do that later. For now, I'm just going to use this. So we have our hero. The way I like to work on pixel art, since I'm using, I can't show you. I'm using mouse and keyboard to these arts. Obviously, you could always use your own like graphic tablet and whatnot, but I like to use mouse when I do pixel art because sometimes like these detail stuff is easier to work with. And I feel like I'm cheating when I don't use mouse, like if I use like a graphic tablet. It looks so silly. It's okay. We'll figure it out. Maybe it's a traditional like stubby-legged character. You gotta trust the process. It'll come together eventually. I promise. This is a lot easier to work with than trying to figure out everything all at once. So, and Slay the Spire is notorious for their like weird characters, right? So, in that spirit, maybe we will have the similar feel to it. So let's see. What kind of character do we have here? Let's see. Why are we in the card place? Maybe it's like some sort of like rogue that throws cards, right? Maybe this is how it's gonna look. This is supposed to be a card in his hands, or her hand, or their hand. Oh yeah, maybe he's holding a little card. And then, you know what? I'm gonna do a little floating head. Just because, why not, right? Like a mask, floating mask. Those one of those thespian masks. Like one of these here. Let me show you. One of these things. It has a good feel to it. Everybody knows what it is. And also, personally, you know, I did theater in high school, so I have a pretty close relationship with that. So it's not completely random when I do that. This looks so bad, but it's okay. The point is, I'm making a character. It could be as good as just a circle, you know? It doesn't have to be that good. You know, I'm trying to get something on the screen, so I'm not too worried. Yeah. Oh, that looks great. Okay, I'm going to change that. So I'm going to change the shadow to be more like this too. I think it's looking good right here. See? I'm paying a lot of attention to the right side. This is very deceiving, so I try not to look at over here too much. And then enemy character is the next one, right? So we're gonna make an enemy character real quick. Okay. I know, this is a very rough job. I'm just like slapping things together. It's not particularly eventful here. I'm not really teaching anything when I do this. All right, what's important here is that I have created a enemy and player character sprites, so then they both have some sort of sprite representation, right? So let's see. We're gonna do some sort of sprite 2D. It's gonna be some sort of sprite. And they're gonna be this. We have player character sprite, which I created, which is 64 by 64. I'm going to place it generally where I want it to be, kind of the center, like that. And then I'm going to add a sprite for enemy character as well. Might have to flip it, but I'm not going to worry about that right now. Then I'll also place enemy somewhere like this. So we want to start this game so that the main is the main thing. Last time I made it so that the main scene is deck in hand. So I need to change that. To change the main scene, you just go to project setting. I like to just type the name of the setting. Run. There's a run here. Application, run. Main scene. Right now it has deck in hand as main. I want to change to main. That way I don't have to do play current scene. In order to start it, I can just click play button and then it'll start from where I am. which is this. Looks like what we want is we want these characters to have some sort of properties, right? The properties are health. And that's it. I want to just give it a health bar. So let's give it a health bar. Traditionally, there is a some sort of progress bar right here. You can see progress bar. That's a default node that's provided by Godot that allows you to have this like rectangular bar that goes up and down based on some value, right? You can see how it changes right here. For example, I'm going to get rid of the show percentage so it doesn't show percentages, and begin to end and to begin, by default, leave it to begin to end. And you can see what the steps are. Let's say max value is 100 and then steps are 1. And then I give it, let's see, 100 as a current value. And then the layout, we want to transform it so that it's wide enough. And let's say it's like 50 pixel right here, like this. So you can see the progress bar changing based on the value compared to the max value. So if I had 200 as max, then 100 would be 50%. So this is an easy way to do a progress bar health. So I'm going to use this as my health bar. So you probably noticed in this tutorial that there are a lot of graphical components where it could be fancier, right? There's a polishing aspect where, for example, when enemies in games generally, when enemy or when player gets damaged, health bar just doesn't drop immediately into where the health should be. It has this like damage indicator, flashes, and then it slides, the health bar slides onto the spot that it needs to be. For the sake of applying functionalities, we don't need to do that. The way I'm working on this game is the way I would normally work on. I want to verify the functionality. I want to make sure that all the components and the data works properly. And then we're going to have that last polishing tutorial / session where I'm going to polish a lot of these graphical aspects to make it work. I'm just setting it up so that when I get to that point, it's easy to work with. And I'll also put the progress bar as health bar for our little enemy character as well. Same deal, no percentages, begin to end. We're going to have max value of 100 with step as 1. Now you can see already that these two separate character node share a sprite and something called health bar. And you can imagine that they do basically the same thing. So this is a great candidate for me to say, hey, save as a branch, and then I make a character. But before I do that, I want to make sure that is all I need. So I'm going to just continue work on this and attach a script and all that stuff before I package them into a little beautiful components. We're going to make a script. So we're going to attach a script here. For the most part, will be shared by all other characters like health controls and stuff like that. So I'm going to make a script called character. So now we have a whole new node character. So we talked about export in order to control some of the functionalities of or the properties of a given class or given group of entities. So we're going to call this a class name character. And they're going to have an export variable called max health, which will be int. And by default, let's say it's 10. And current health equals int. And then it'll start with 10. So you can see once I do the export variable, as usual, you have these values right here that shows up on the inspector for me to control. Making a function called like set, health values, that which takes current health and then max health as a parameter. And then it allows me to change the max health of this class or of this instance accordingly. Let's do underscore here. Max health equals underscore max health, and then health equals underscore health. And then after setting the value, we can update the health bar, the status of the health bar, to represent these values accurately, which means whenever I set the health value, update it. And another way to do it is to do it under the process, which loops every time. The downside is that this check happens every so many seconds. So then you're saying, A, you're impacting potentially the performance, you're increasing the calculation time or impacting the amount of calculation that's required on every loop. And that's a valid concern. But once again, we're going to get to it when we need to do it. So I'm just going to do it this way for now. We're going to change the value of this progress bar called health bar, and I'm going to make sure I type it as progress bar so that when I do a little dot afterwards, I get a proper autofill based on that class. So we have max value will equal to max health, and then we have health bar value will equal to health. Now, if you recall from the card session, we want to have the graphical update as its own function, because in games, there's a lot of reason why you would want to just update the graphics only based on the data. Because you might want to do multiple calculations, multiple setup of the data changes without updating the actual graphics sometimes. And it allows me to quickly flip over to the other way. If I decide, hey, this is just going to be a data setter, and then I want the graphical update to only happen on a loop, then all I have to do is call that. So I'm going to do that right now. So I'm going to have a function called update health bar, which is a graphical update. And I'm just going to do this where I change the value to the global variable, and then either I can call it here or I can call it here, which will be every loop. And you can also do this by checking some variables being like, hey, to make this more efficient, I can say, hey, do this only if health bar's max value does not equal to max health, or something like that. Which, I mean, sure, why not? I'll do it here like this. So do this update only if it needs to be done. And then I can do it on every update. We're editing this, so we could always add a little tool tag on the top of the script so that it actually runs within the editor. Once again, the tool tag makes the code run in the editor time, not the runtime only. So it allows us to change these values and see it impact the graphics immediately. So I'm going to reload the project because I added the tool tag, and we're going to see it reflected. Hopefully it doesn't break here. Okay, so you can see right here already it's filled up 10, 10. So if I update the max health to be 100, right, 10 out of 100 is only 1/10. So it looks like this. If I change to 100 here, updates like that too. So I'm going to just set it to default value. And guess what? Because the setup is exactly the same, I could just drag and drop the character script onto the enemy character as well. And it should work exactly the same. Now, once again, it does require me to reload like that. And then it's now updated. Okay, now that we have a character, we can actually make them fight, all right? So right now, what's the game mechanic, right? I'm just going to work with what cards we have. We have two types of cards right now. Okay, let me say this one more time. So we have two types of cards right now only. We have the attack card that says damage 1, and then we have defend card that says +1 defend. Actually, we should just do defend 1. And I'm going to make it mean a very simple thing. When you use an attack card, it deals 1 damage. When you use a defend card, it can block next damage. So first thing I want to do is I want to be able to test whenever I make the functionality for defend card and then the attack card, right? I want to be able to start the game, add whatever card I need, like attack or defend card, as if I drew it from a deck. So there's going to be a debug function that allows me to add any card I want, and then I want to be able to click on it and then make it happen. Luckily, I already made that functionality, right? So what I did last time, I made it so that if I click create card 1, it creates an attack card. If I click create card 2, it creates a defend card. Now I'm going to come here and then change the text here so I know exactly what's going on. Add attack card and then add defend card, right? And here I have that button already here, so I can just start it and then it's right here. And you can see I can just add the cards. Now, one thing you probably noticed is that it's covering the screen, so I want to lower the cards. I'm going to do that. So I'm going to go to deck and hand here, and I'm just going to lower the position. I'm going to make it 1300. Perfect. So it's going to look like this. Bam. This looks great. Okay. Remember, we use a signal to propagate the click event up the chain so that whatever is overwatching or whatever contains all these components can listen into what its component is doing and react based on that. What we're going to have to do is in the main game here where it holds both the game screen and the deck in hand to be able to receive the event of clicking the card and then decide what to do with it. So we're going to go to deck in hand. And we made it so that the hand, if you look at the hand script, the hand actually handles when the card is clicked, right? You can see right here in the input event, we have mouse click, which I already registered. And here I made it so that it removes a card and then it pops the card that has been removed, like the actual card object. So now that I have the card and I removed it, I want to be able to propagate that up. Right? So the hand will say, hey, here's a signal, card activated, right? And it's going to send a card up. Ideally, in a real situation, I want to type it into certain things, but right now this is all we're going to do. You know what? Enough being lazy. I'm actually going to type this now. So what happened here was that I typed this base card in the attack card that represents the whole default base card. And then there's a wrapper card around it where it holds the image of the card and then the card itself and then the script that's handling the interaction with the card. This is a usable card. So I'm going to class it so that I can just type it. So whatever function I attach to this for both attack and defend can be autofilled in the GD script editor. So let's call it class name. I want to use card, but then the card is already taken. So what I will do is I'll name this usable card. Usable card. Now that it has a type, when I go back to the hand and its script, the signal will return a usable card. We have a hand script. We added a signal called card activated. And then we want to emit that when we detect a mouse click on the card. So we have mouse click, we remove the card, and then we want to emit that. Card activated, emit, and then I'm going to do card like that. So now it's going to send that signal up from the hand. If you look at deck and hand, the hand has this thing called card activated signal. And I want to propagate that up. I don't know if there's a better way to do this. Like, I want the unhandled signal to propagate up automatically and then make it so that the node signals that too, but I don't think there's a way to do it. So I'm going to have to do that again. Signal card activated. Card equals usable card. And we're going to make it so that when the hand, now that we have all this set up and we have the main here, which will have to have its own canvas layer, I don't think we need the hand to be in the canvas layer. So I'm just going to pull it out and delete this. I'm just doing a little bit of cleanup here. Anyways, so I'm going to double click on the card activated and then make it handled by deck and hand. And I'm going to emit that exact same signal, like so. So that when I go to the main, which also includes deck and hand, will see the signal. So I'm going to double click, and I want to handle it in main, right? So I'm going to create a new script called main script. I know I'm very inconsistent with the naming capitalization right now. You definitely want to be a little bit more consistent just for the sake of sanity. But yeah, do as I say, not as I do, I suppose. The years of software engineering I've done in actual like industry, I realize this type of like best practices or like engineering excellence, they call it, is very important for the sanity of everything. But like minute things like this, it doesn't really have a major impact. So I don't know. Put it down in the comment if you are used to having certain standards that you have to follow. Like why is it that you want to follow this so strictly? Like, is it justified to be so angry and passionate about it? Maybe. I don't think so, but you know. Anyways, back to making the card work. So we have deck in hand. Cards activated. I'm going to double click on that and make the main script handle this. All right, we're almost there. So now we have a main screen with the characters where we can have and add the card. When I click the card, the signal propagates all the way up to the main with the card itself, right? And one thing I want to do is I want to be able to say, hey, card, do something. That's what I want to do. So there's two ways to do this. It's always two ways, all three ways. I just like to think about two major different ways. So I have a card. One way to handle it is, hey, what is the type of card? So in here, in this line, I can say, hey, if card equals like, or card type equals attack, do something, right? So based on the card type, the logic of what the card should do is handled by the main game logic. The good thing about this is that you have all the card logic in this single space. You know where to go to figure out what they do, and they are all seen in a single place. Maybe you can have multiple controller, handler, different functions to do these things to better organize it. But yeah, it's simple. You can see, hey, card itself, the object itself doesn't do anything. I don't have to handle complex coding logic in different places. I just need to do it in this one script. Good argument. I don't mind doing that. But the way I want to do it is actually for the clarity, and this also helps with the organization. I just want to be able to say, hey, card, do something. And then maybe I have to pass in like game objects that it requires to do something. That way, each card handles its own functionality, and all I'm doing is like, hey, here's an object. The main game logic, all it does is that it injects and handles the game objects instead of actually handling what needs to be done based on the card. And to me, it's pretty good design. I like this because let's say I implemented something for the card itself. Like, so the card has a function that says do something, blah, 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 based on these objects. When I'm testing, I can just give it any type of objects. I don't have to go through the main logic to set up this object. I can just say, hey, here are the game objects. Card, are you functioning given these parameters, right? That's a very important word. Given these parameters, card, are you good? And good thing about this is that it's isolating card's functionality by itself. So when something's wrong, I can at least say, hey, card's functioning. It must be somewhere else that's wrong. Or, oh, it must be in the translation between these objects is wrong. As opposed to being like, is card wrong? Is translation wrong? Is everything coming together wrong? Like, it's hard to manage that. So having it handle itself with the kind of like as a black box allows us to say, hey, we can test it independently. And this is kind of like one of the main thing about the object-oriented design. Some people might say, hey, it's not necessary To me, this is the way I've been working with programming in general, so it makes a lot of sense to me. So this is what I'm going to do. Of course, I provided these two options because I'm saying it's neither are right or wrong. Based on the situation, you might have a better experience with one way or another, but at the end of the day, it's preference, it's your game, so do whatever you want. But in this case, I'm going to make it so that the card handles its own logic, and then the main game logic only handles data organization. Sounds good? Okay, so let's do this. So instead of card do something, it's going to be card activate, right? And then we already said card's going to have a usable card. Okay. I'm running out of breath. So usable cards, which is attack card and defend card, is going to have a function called activate, and then it's going to take a bunch of game objects, or game objects, let's say, or game object handler. We'll talk about this later. It's not going to be important right now. Well, it will be important very soon, but right now it's okay. This is all we need to know. So we're going to call activate. And once again, because this script is shared between the attack and defend card. Oh, it's not. Why is it not? Oh, I guess at the time I was like, hey, I'm going to make a separate card because I want them to do their own thing. That's not what I want to do. Oh, boy. All right, there's going to be a minor surgery here. So the decision I made that was wrong, I guess, was that for two separate scenes, attack card and defend card, if you look at it, they do pretty much the same thing. I made a two separate script because I was anticipating that they're going to hold their own logic and it's going to be its own thing. But that's not the design I want to stand by. Because they're doing the same thing, I'm going to change this attack card script and rename it and say it's going to be usable card. And then I'm going to open defend card scene. And then I'm going to change the script. I'm going to detach this and then attach the defend card. Yeah, usable card. And defend card script itself is going to be no longer needed. So what did I do? I changed it so that both of these cards use the common script called usable card. So you might be wondering, hey Ezra, attack card and defend card is going to do two separate things. How are you going to handle that within this single script? Are you going to have if then why not do it above? That's not what I'm going to do. I'm going to use the kind of thing that I think Godot is intended to do. So follow along with me here and bear with me. It's all going to make sense and I'm going to explain what I'm going to do here. So we have an attack card, right? So I'm going to create a new node and call it attack action. This is an attack card action. And then I'm going to create a script called attack action and then put it under scripts. Maybe I will even put it under cards. And then I'm going to create this. We have activate. Let's say I have an activate here, right? And in the attack card, we have activate here. What we want to do is we want to basically do one of these. Attack action dot activate. And of course, we want to pass in the game object. That way, the usable card itself is not handling what happens. It's the action component that handles what happens. All I'm doing is I'm routing this activate into the appropriate action. This way I could have series of actions if I needed to that I can activate one at a time. So problem is right now it's hard coding attack action. I'm not going to call a node called attack action from defend card. And that's a problem because they share, the attack card and defend card shares the same script. So what do we need? We're going to use another export variable here. So we're going to say export var action, and it's just going to be some node 2D. I could type it, but that could get kind of hairy with hierarchy. Like I got to make a parent called action, and then I have an implementation extending the parent, blah, blah, blah. All that good stuff. I'm not going to work on that right now. I should. I'm not. I'm just going to do this. So we have attack action. Instead of hard typing it like this and directly calling activate on this, I'm going to call activate on an action object. Simple enough. And it's an export, so attack card has this action. I'm just going to simply drag and drop here like that. Bam. Beautiful. Another one. So what happens with the defend card? Add a child node. We're going to have a node 2D. Call defend action. And defend card is going to use defend action. And I'm going to attach a script called defend action. And we have this. And this will also have activate. We talked about handling game objects, right? So let's see what we need in this object. If we go to the attack action, what do we want to do? We want to be able to spend mana, and then we want to damage 1. Simple enough. So we're going to say spend cost and then damage 1. And I'm doing this like this so I can kind of figure out what I need. In order to damage 1, what do I need? I need a target component, like the enemy object. And then in order to spend, I need to know what mana the player has. So I need player entity, and then I need enemy entity. And we can pass that. So from the main, it's a little bit complicated. I want to be able to say, hey, here are the game objects. This is the caster, and these are the targets, right? We're going to say caster is a character, and then targets will be array of characters. But as I add more cards, I might realize I need more parameters. Does that mean we need to continuously change every single action every time I update new card, and then I realize there needs to be a new thing? And answer is, in the current form, yes, that's what's going to happen. Another way to do it, and I'm okay with doing this right now because I rather have this hard typing than the other way, but the alternative is to have some sort of like amorphous object, like a Node2D or a dictionary, where it doesn't have any requirements in it. So for example, instead of doing caster and targets like this, I could just have objects that are dictionary. And the dictionary will have something like character or caster is something, and then targets are something, right? So if I pass this, I can just say, hey, I need a caster. I'm just going to say objects.caster and then do something with it. Objects.targets and do something with it. Right? And then if I want to add something, I can always add something like, hey, allies, for example. If I don't use it, if the action doesn't use it, it doesn't need to update anything in the function. And if I do use it, I can just access it now, where I say objects, allies, and blah, blah, blah. Right? And that's nice. That's nice. And that's probably what people would and should do most of the time. I still want this to be hard typed, so I would rather pass in an object, like actual resource instead of dictionary, like resource called game object, where it's hard typed so that we define exactly what goes in this dictionary per se. But as of right now, that's not what I'm going to worry about. I'll show you the example of doing it as a dictionary. So let me just do it as dictionary. So I'm going to update this to be dictionary parameters. Instead of calling it object, let's call it game state. Game state, I guess, because it is a game state. So let's call it game state. And we're going to have dictionary as game state so that I can have whatever I want in it. And I don't have to modify it ever. Okay, I jumped around a little bit. So what I'm doing here is I'm going to the usable card and go to the activate and change the game state change the parameter to game state and make it dictionary and pass it. And now the two impacted actions, because I call activate on actions, are attack action and then a defend action. So this will also take a game state dictionary. Simple. Instead of game objects, we want to pass in some sort of dictionary. And the dictionary will have caster, which will be player character in this case. And then targets will be enemy character. For now. Obviously, we don't want to do it this way because caster changes every time. So like hard coding it like this, it might not be the player, it might be the enemy, it might be second player, it might be a multiplayer. But right now, the point is I made the card be able to handle these things. And for the sake of testing functionalities, I'm going to hard code it right now so that I can speedily go through it, confirm and verify the functionality, because changing it back to the general form after confirmation is not that much work. For me right now, figuring out how to generalize this is more work. I want to get to the fun part. You may not agree with this method, but it's the way I do it. Anyways. So right now, what do we have? We made it so that when the card is clicked, signal gets propagated, and in the main script, it activates the card. Card.activate is pressed up on the main. Why did we have to come all the way to main in order to activate? Why couldn't I do it in deck in hand? Because it's the main script that has access to the game state. Of course, you can have a singleton that is a global script where you can access the game state from anywhere so that anyone can access those values so that you don't have to pass anything. That's an option, but I like this better. Oh, my light just died. I'm going to have to redo this just a second. This might be a sign that I should probably take a break for today, but I'm going to try to do maybe like 10 more minutes. Okay, let's finish this up. Let's finish this. I just want to be able to damage my enemy today. That's all I want to do. Let's do that. All right, so we have this. We have activate. So what should the attack card do? The attack action should game state. It's going to grab, that's a dictionary. Do I have to get? Yeah, I think so. Get the character, which is going to be a character card. And then going to say spend mana. It's going to spend 1 mana. And then it's going to get targets. And I know I hard coded this. It's going to be an array of characters, but I know it's going to be 1 target. So I'm just going to hard code 0, and then damage 1. That's what it's going to do. Now you probably noticed these are character functions called spend mana and damage. I did not implement this yet. So there's no such thing as spend mana and damage 1. So if I run this right now, it's going to break. It's going to be like, hey, spend mana doesn't exist. Damage doesn't exist. So I'm going to do that right now. So I'm going to go to the character script right here, character.gd. And I'm going to say, hey, function spend mana amount. And then I'm going to have function damage or take damage. Let's call it take damage amount and int. Whoops. All right. That means I need to update the attack action to, instead of damage, called take damage. Cool, cool. Now we're going to go back to character here. Spend mana means I need to have mana. So let's say I have mana. Let's start at 10. Of course, the game mechanic will make it so that it increases 1, 2, 3 every turn. I'm going to implement that later. I just want to be able to spend mana. Not even check if the mana is there or not. Just spend mana. So it's going to say mana minus equals 1. And then take damage, we'll do health minus equals 1. So this means take the current health value, minus 1, and set it to health. Most of you guys already know, but I'm just going to explain this just in case there are beginners amongst us, beginner coders. This health is a variable we're setting, right? We want to set this to health minus 1, right? The shorthand in program will be something like this. This means this. And otherwise, this means this. Now, obviously I did this wrong because I don't want to do 1, I want to do amount. So we're going to reduce the mana when spam mana by the amount. When we take damage, we're going to reduce the health by the amount. Oh, shoot. Oh, my camera just died. It's okay. For the sake of this last part, I'm going to do it without camera. You don't actually need to see my face for this anyways, right? Let's finish this up and I'll come back to my time tomorrow to continue. But okay, where were we? We were at action, right? Attack action. So we said when it activates, it's going to take the character, spend mana, it's going to take the targets, the first target, the 0th index, and take damage. And then I went to say, hey, character needs those functions, so I did these functions. I want to be able to confirm that this happens. The take damage happens because health updates on every loop, so it's okay. I don't have to worry about setting it up here. Now, another thing, mana, right? I don't have a mana indicator here, so I'm just going to create a mana indicator over here. Not for the actual thing, but for the sake of debugging. So we have a label. Say mana amount. And I'm going to write 10 here. And then it is up here, I believe. I'm just going to move it over here to show that mana amount is over here. Let's put it over here, 10. Okay. And what else am I going to do? On the main, and of course on the process. This is pretty janky. Yeah, I'm not going to lie. I'm just going to make it so that every process, I'm just going to take the mana amount, mana. I'm going to take the mana and then make that into string. Once again, this is not the best way to do it. I'm just doing this so that I can check my functionality and update the mana amounts, which is a label. It's text to this, right? This should work. So let me play this real quick. So we have 10 here. We have this. Gonna get a tech card. It broke. All right. Let's see why it broke. It's trying to add attack card, and then attack card doesn't exist. How about defend card? Is it just the attack card that's broken? No, it's not. Card exists. Attempt to call function add card in base null instance. Is hand null? Oh, hand is null. What happened to the hand? Is the hand script broken? No. Oh, okay. This is what happened. Remember, I had a canvas layer here and then hand, and I popped the hand over to outside of canvas layer because I said, we don't need canvas layer. Well, in deck and hand, I made the hand be this. So this needs to be updated to be just hand like that. That's why it was null. All right, now that that's fixed, ta-da, attack card is added. If I click it, I should see this go down and this go down. It says non-existent function spend mana in null. Oh, character, right. This was wrong. Remember, see, this is what happens when I try to do it rapidly. You probably know already. Maybe you were already yelling at me for doing this earlier. So in the main, I call this caster, not character. So it should be caster. See, this is the problem with using dictionary. Like sometimes I get the names mixed up, you know? If I use a hard-typed game object or resources, that's why you want to use a hard-typed game object and resources so that you don't make this type of mistakes where you're like, oh, I forgot what I called it and stuff like that. Because it'll break before I even play it. It'll say, hey, that doesn't exist in this object. So a little lesson here. Maybe tomorrow I'll fix this, but let's figure this out real quick. All right, change the caster, click. Oh, look at that. Click, look at that. Yeah, mana spent, damage has been dealt. Perfect, it's working. This is great. I'm gonna let my camera charge up. It's late anyways. I'm gonna stop this recording. We'll continue tomorrow. I'll be right back. Okay, I'm back. As you can see, it's pretty dark right now. Despite how it looks, it's 1 in the afternoon here in Seattle. Seattle is doing Seattle right now, being all rainy, which makes it the perfect weather for game development. So I can just stay put at home and finish what I was doing. I'm pretty excited. I thought about it a little bit. I think I can get a lot done this session. Well, before all that, I'm gonna get my little sip. Ooh, I usually get Americano because I'm a very basic person. I just want my coffee. I want my fragrance. So I got this thing called the Magic Tonic that's going on right now, and it sounded fun, so I got it, and it's delicious actually. It's probably really sweet. It's got the elderflower tonic, grapefruit syrup, and cold shot, whatever that means. I've heard of cold brew, I've heard of iced coffee and all that stuff. I know those. I don't know what cold shot means. Like, is it just mean shot over ice that makes it cold, or is it like pooled specifically to be cold? I don't know. That's not important. We're back here on second session of the episode 2. I believe we finished at creating an attack card that works. So if I use an attack card, a mana will go down by 1, and then health will go down by 1. There you go. Yeah, I remember. Okay, now it's time to do a defend card, right? But how do we test defend card? Immediately right now, if I want to test defend card, I need to be damaged, right? First, in order to be damaged, I need to probably either create the AI so that AI is functioning so it attacks me, or I need some sort of a button to inflict damage to my player. So I think I'm going to do that real quick. I'm going to create a button real quick for damaging player. Damage player. How about inflict 1 damage? Ideally, you want to have probably some sort of ways to do variable damages so that you can test for different cases. But for this experiment, for this particular use case, I'm just going to have 2 buttons, inflict 1 damage and inflict 3 damage. Inflict 1 button, and then I'm going to name this inflict 3 button. And we all know how buttons work now. As always, we click the element, like the button, and you can see here it has a signal pressed as usual. I'm going to let the main handle it, and I'll do the same for inflict 3 button. Same, double click on the pressed, click on main. Now that we have the button connected, we want it to inflict damage to the player. What we're going to do is I'm going to make an export and then player character, which will be a character type. And I did an export so I can connect. If you go to inspector, as usual, oh, this is supposed to be var. Export var player character is character. You can see right here. So I'm going to just drag and drop this player character node. I'm going to just simply do player character take damage. And then this is 1. And then for button 3, it'll be take damage 3. And as you can see, if I play it, it should just work, right? You can see it right here. Now, of course, it goes to negative because I don't have kind of like the capping of how much damage can be inflicted before it kind of game over screen pops up or whatever. But that is a game element, game logic that I will handle later. I don't have to worry about like the limits of like, hey, check if the mana is available before using the card, before subtracting it and all that stuff. That kind of stuff can be done later. So what do we have here? We inflicted damage correctly. So now we want to implement a defense card, right? So the way we did the cards were for each of the card scenes. I mean, I have the tabs already open, but you can just go to the scenes, cards, and you have attack and defend card. If you open the defend card, you have this defend action that we added last time, and it'll have an activate function. And it takes in game state as a dictionary. Once again, I wish it was typed. Maybe I'll fix it later. For now, I'm just going to do it this way. So remember, I want to do game state, and this is activated by the caster. So I want to say get caster, so it'll get the character that is a caster. And then the caster will probably do add armor, let's call it. And then this particular defend card adds 1 armor. And also, we made it so that it costs 1 mana. So we'll do that too. Game state. Get spend or caster spend mana 1, right? Now another way to do this, probably better way, is say caster is a character type, a variable, and then I'm going to do this like that. And on the caster, I do add armor and spend mana. What's wrong with this? Well, we don't have add armor function on these character scripts. So that's what we're going to add. I have it open already here, but if I remember correctly, it's under scripts. Yep, here we are, character GD. And we're going to add a function called add armor. Of course, another amount, and then armor plus equals amount. And of course, we need to add that variable, export var armor. By default, there's 0 armor. So the game mechanic I'm thinking is, by default, there is no armor unless you do an upgrade, maybe if that's a thing. And then when the card is used on that particular turn, armor will go up. Now, we could just do that and trust that the armor is there. But of course, these are the kind of like parameters that players should be interested in. So I think I'm going to create a little icon on the health bar showing how much armor the character has. So let me make that armor image. Maybe 16 by 16 is good size. And something simple, I'm still going to use the same palette. This looks pretty good. And then I'm doing hard dark lines because it's an icon. I want it to pop up. So the player will have another sprite 2D, which is armor. And then I'm going to use the sprite for that little armor icon, drag and drop. A little cute armor icon here. And maybe that'll be above. Now, ideally, maybe the kind of UI improvement that I will add later is somehow indicated by hardlining the health bar with the little armor indicator to show that the health is armored. Maybe that's a good idea. I don't know. But for now, I think this is good enough. I'm going to make it so that the armor pops up here. And then I'm going to add a little label, label component here. Next to it, that's gonna be like this. I should probably, I want it to go left to right, so horizontal alignment will be left. And then the vertical, I'm gonna do a centered. Here, let me use this and see what the font looks like. Okay, I gotta do new label setting. Under font, I just drag and drop my font that I'm using. Doesn't look half bad. 16 doesn't look bad. That's good. Same deal, probably. I'm going to do that on the anime character as well anyway, so I'm going to add that to the anime character as well. We're going to make a logic to display the armor icon appropriately. So the way we have been doing it is we have this update health bar that's being called on every loop. So what I will do here is I'm going to make another function that says update armor status or icon, maybe. So right now I'm trying to be like, hey, here's an armor icon label, and I'm going to update the text to equal to the armor value, like this. And then also I'm going to make sure that the armor icon is visible instead of being hidden. And of course, there's all this logic. I'm just showing you this right now as an example. So the problem with this is that this this character script handles the subcomponent of the armor. Like armor has its like complicated values within it and components within it. And the parent, the character node, is aware of all the things that are going on by the armor and handles it. Good thing is that all the logic, you know where it's going to be. All the logic relating to the character, including its armor display, will be in the character script. Bad thing is that it can get complicated in terms of like managing, hey, is this label armor's label or just label? So then you have to mess with naming. And then when you're testing also, like it's not, you can't like component wise test the character node per se. I mean, you can, but once again, just like conceptually, it's not well organized. So some people might be like, hey, I like object-oriented programming, so I'm going to make a armor icon class and then have that handle everything instead of doing this. So here, instead of doing armor visible blah, 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 I would say something like armor icon update armor display, and then hand over the armor data, and then it'll update the graphical components of the armor. Sure, that works too. It's just kind of deferred calling. Do you need to do that? No. Is it better organized? Maybe. In this scale, though, I don't think it's that much advantageous. I prefer kind of flattening out the levels as much as I can, so I don't have to worry about, hey, did I make the script for that? Did I make the script for that? So right now, I'm just going to do it in the player character. Wow, that was a really long-winded way to give myself an excuse to do what people call a bad object-oriented programming. But there's no good or bad. There's only what works and what doesn't work. So when we're updating the armor icon, what we want to do is we want to make sure if the we only do the display thing when the armor value is actually greater than 0, right? We want to make it visible and set its value only if armor value is greater than 0. Otherwise, we want to make it false. Now, of course, I could do this, which I actually prefer doing. Like, I don't like doing these like ternary operation or like being a shortcut that is less readable, because this is clear, saying that, hey, when the armor is greater than 0, make it visible and set the text. But some people might prefer something like this. So visibility is true if the armor is greater than 0, otherwise visibility is false. So it's a shorter line. It's like one more execution, so it doesn't matter, but you know, I'll do it this way because some people might yell at me. Ultimately, it doesn't matter. If I was code reviewing this and somebody sent me this versus the other way, I wouldn't nitpick at it. It's like 3 more lines at most. And one is prioritizing cleanliness and the other is prioritizing readability. So like, pick your poison. We're almost there. We're almost there. So we have that. Update the armor. Oh, error is going crazy. Because remember, we made this a tool. That means all of this command is actually currently actively running. The process is actually actively running as the editor is on. And what it's complaining about is that it's invalid index text on the label. Oh, maybe it should be set text instead of text equals. And then it won't be armor is int, so I got to turn it into a string because they're very strict about that. GDScript is at least. And voila. Gone are the errors, and only happiness and flowers flourish. Okay, error here. I dragged and dropped it, and it did the path wrongly because I dragged and dropped the enemy character stuff. Even then, it should update this. But anyways, what this should actually be is just armor, and then just armor label. Like so. Yeah, right here, 2. So you can see right here, player character, I can lower it to 1, 3. If I go to 0, it goes away. Cool, cool, cool. Enemy character, same deal. Yeah, because it shares the code. Cool. Armor display is working. And then I also implemented the defend card action to add the armor. So right now, if I use the defend armor, the icon should pop up. So for example, right here, if I use the defend card, bam, another defend card, bam, and mana is used as well. Now, it does that, but it doesn't actually work, because right now, right here, if I play the game, let's say defend card, I have an armor. If I inflict 1 damage, I shouldn't take any damage because of the armor, but I do. So I need to implement that part. Question for myself here for game design. Do I want the armor to deplete after it's being used, or do I want the armor to stay for the whole turn? I'm trying to see what's more interesting. Because if the armor stays for the whole turn, and if there's like 4 different attacks, and you're negating those attacks for this turn, doesn't armor feel kind of OP? It might be. But you know what? I think it's okay. I'm going to do that, and maybe I'll adjust it later. See if there's different fun interaction that comes up. So for now, I'm going to decide that the armor stays on for the whole turn. And then once the turn is over, the armor goes away. Okay. Having said that, what I need to do now is when the damage is being inflicted, so I'm going to the character script again. And remember, this character script is shared for everybody, player and the enemy, so it's the same logic. When the damage is incoming, the amount of damage that the player takes or the character takes will be amount minus the current armor value. And then we'll subtract the damage amount instead of just the amount. Cool. Potential problem? What if the armor is greater than the damage amount? I don't want that to heal the player, so I gotta make sure that the amount minus armor, if it becomes negative, it sets to 0. The kind of like beginner programmer way to do it would be to put another if statement here or ternary operator to make it so that, hey, if it is negative, set this to 0. More seasoned programmers would simplify this line by doing a max. So what this would do is that it chooses a max, or chooses a greater of the 2. So min would be smaller of the 2. I've used this before, I think. So it'll take the value amount minus armor and then compare it to 0. And between the 2 numbers, it's going to choose whatever is bigger. So while positive, amount minus armor would be always greater than 0. So it'll always be picked. At 0 and smaller, like negative values, the 0 will be picked. So damage will be 0. Cool. So this should work now. So let's test it. Play. We got attack card, defend card. We're going to inflict damage. 1. What if I take 1 armor? No damage is being applied. If I do 3 damage, 2 damage should be applied. Yes. If I have 2, only 1 damage. If I have 3, no damage. And it doesn't heal the player. Perfect. And attack still works. Hey, we kind of have a somewhat of a game going now. We have the defend card, we have the armor, we have the attack card. Now we need to make the AI. I think that's probably a good idea. So let's make it so that there is a actual game loop. Oh, we're getting into the game loop. So game loop would be player's turn, player plays the cards, enemy turn, enemy makes the move, and then back to player turn, and then repeat until somebody dies. So we're gonna do a basic game loop. And when it comes to game loop, what is it? The solid state machine? Is that? I forgot. It's been a while. Anyway, some sort of state machine is kind of standard. So especially turn. There's, I'm sure, a bunch of great resources on state machine. It's kind of a must in game development. Vending machine, for example, like vending machine that you vend sodas out of uses state machine. A lot of the mechanical, I guess mechanical programming and like electrical engineering machines type of situation uses state machine as kind of the thing. And it's like a glorified if then statements essentially. But you've seen this before where there's like a flow chart of state. So you have state 1, state 2, state 3. Okay, you know what? I'm going to bastardize this really quickly. A very, very rough and incomplete explanation of state machine. Obviously, if you know, you can skip over this part, or maybe you want to check. Actually, if you know already, check me so you can comment so that I don't mislead anyone out here into oblivion. State machine basically is you have certain states, a mode, and then you determine the flow between state to state. And then there are conditions that needs to be satisfied before the state transitions. So for example, I guess vending machine is probably a good idea. So vending machine by default, jeez, what am I doing? So vending machine by default has a, it waits, it's waiting, right? And nothing happens. And if the coin exceeds, let's say, a payment, then it goes to, let's say, vending mode or order mode. And this is just an example. It probably doesn't work like this. It's probably more detailed than that. But anyway, so it waits, coin comes in, and if the coin is greater than the payment or the cost, it goes to the order. And then if the player presses a button of the drink, then it goes to vend mode. And then once the vend happens, if during that vend mode, it's going to execute certain commands like, hey, grab this drink from this coordinate, drop it into the bin. And then once everything resets, if reset, go back to the wait mode, and then you have this like operation. And you need this because you have different behaviors that you need to execute and different conditions you need to wait on before moving on to the next mode. And this is perfect for card game, right? Or not even card game, but just in game general, because a lot of the games operate based on this, right? Think about AI movement, right? AI often does, hey, it's doing a searching for players mode, and if the player has been detected in the line of sight, then it has like this determination of if they're low, start shooting, if they're high, start running away. That type of like AI logic is state machine. Also, the game order, for example, we are at title screen, like the title screen of the game. And then we are at game playing mode, like we're playing the game. And then there's a whole thing about if the condition is paused, then do this and that, like a bunch of complicated things. It can get pretty complicated. This is a poor man's version of that. But for my game right now, what I want is I want player turn, right? And then enemy turn. And then it just goes back and forth. Of course, there's something in between, right? There's an enemy turn can be further broken down into something like decision, verify, probably, execute. At any point, anyone's turn, you have something like game over. If player HP is less than equal to 0, you know, same thing here. Then game over, and then you have victory, you know, other way around. If enemy HP is 0, and there could be multiple win condition. So you can see like there's some sort of like basic state machine for this game, right? So this is how you can think about it. There are several ways to approach this. I'm tempted to use my own dialogue manager as a state machine manager. And that might bite me in the butt. You know what? Not everybody is going to want to download my plugin, so maybe I won't use it. So for now, I'm going to do it kind of like the if-then mode of like using enums and all that stuff. And then later I'll show, I guess, in future episodes what that would look like with using my dialogue manager as a state machine manager and why that would be beneficial or not. It might not be. And that's something that I need to figure out. It's just like my natural instinct tells me to do that. And it's hard to explain why. Because there are a lot of little things that I built up over the years of like, I have experienced things and then I made certain logical decisions to, by default, shortcut to certain decisions in my life that sometimes I can't explain my intuition and I have to think about the reasons why I have that intuition. So for now, let's simplify and then we'll just do it in code. Long story short, we want to make turns. That means we want to have state machine. And of course, I'm going to handle that game states in main because main is executing it. You know what? I want to make it standalone. I'm going to make a node. So we're going to make a empty node. Okay, so I'm going to attach a script called games controller. And then under the script, I'm going to make this game controller script. So we have class name, game controller. And of course, we're going to have some enums. I'm going to look up how enums work in GDScript. GDScript, enum. Enum. Okay, this is how I define enums by doing a little enum, curly brackets. So what do we have? We have the enums, which will have player turn, enemy turn, game over, victory. All right, something like that. This may change in the future. I'm just starting out with this. And then I could say there is a current state. Oh, let's name this state. Game state. So this will be type game state. And then it'll, I guess, start with player turn. Like that. Yeah, okay, cool. So I'm just going to do it on ready like this. Okay, so by default, it starts on the player turn, and then it's going to go through blah, blah, blah. So the logic here would be something like func, how about transition? And then we're going to have next state, which will be type state, game state. And then current state will equal to the next state. And it's going to, based on what state it is, right? We're going to have current state. Wait, is there no switch in GDScript? See, we're learning. Reason why do I want to do switch here? Technically, in more different type of languages, switch is slightly faster than an if statement because it has certain commands built in, blah, blah, blah. It doesn't have to do the math. The math is simple as doing subtraction on the address as opposed to doing actual comparison, blah, 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 blah. All that is to say, when I do game state, when I was learning it back, and when I learned to do switch statement instead of if-then statement, whoops, not Nintendo Switch, GDScript switch. It may be that the GDScript, because it's a scripting language, it may not actually have that kind of same, same optimization. Okay, here it is, match. It's using keyword match, and then you can do this. What about break? Do I need break for this? If a match is found, it'll break out of the structure and the remaining pair will not be violated. Okay, so it is not, it's just like glorified if-then statement. So it does behave a little differently. All right, well, here it seems like it's mostly a tool for convenience and readability as opposed to actually having a functional speed advantages the way it seems to be implemented, but I'm going to do this anyways. So we have match current state, and we're going to do game state, player turn, and it's going to have some sort of function, and then game state, game state. I'm going to do that for every state. All right, so the idea here is that we have a game state controller. It should be probably called game state controller, but essentially it's going to be at certain state, and then the game will demand that it goes to the next transition, and then it'll give the next state, and then it'll, based on what state it is in currently, it's going to execute certain type of behavior as it exits a state. And then as it enters a new state, it probably should do some more behavior. That's typically how you want to handle state machine, is that you want to have a transitional behavior, right? Because you might want to reset certain variables or certain state variables when you're leaving a certain state, and then when you're entering a certain state to make it work. And then within this state, you have a loop where it says, hey, as long as you're in this state, execute these things, type of thing. So we have this. Simple enough on the main. On ready. We're going to have a game control. And by default, I'm just going to use this. Controller. So I'm using this. I just dragged and dropped. So we have a game controller that manages state for us. And then, so what we're going to do is that we're going to assume that current is a player's turn and not do anything for it. And what we want to do next is that we want to consider enemy's turn. We're going to say if control current state equals enemy turn. We're going to do some sort of AI logic. When it's done, it's going to probably call the game control to do transition to player turn. Not complicated. I think I mentioned it before. I'm going to make it so that the AI does 1 defend, 2 attack, 2 defend, 1 attack, and 3 defend. Like, that's going to be its pattern. It's just going to keep incrementing and then rotate through that. I'm going to get the enemy character, and let's make a little variable called enemy character state. And then I'm just going to call it an int, and it's going to rotate through 0 through 0, 1, 2. If enemy character state equals 0, elif enemy character state. This is another great spot to use what they call match, what I call switch statement instead of if statement. But, you know. So what's going to happen is that I'm expecting this enemy state to go through either 0, 1, and 2. And after executing its mode, it's going to increment itself. Enemy character state plus equals 1, so it goes to the next part. But remember, at 2, if it does plus 1, it becomes 3, and I want it to reset to 0. And this is where we use, whenever you do a cyclic addition where it needs to go back to reset to 0, we use what's called mod. In Godot, they have something called pause mod. If you just use mod like the %, like you're used to, it allows, so the mod in GD script allows for negative number. Or you do something like state equals +1 mod 3, right? Because there's 3 of them. What this means that it's the remainder. What computer science people call mod is different from what mathematicians call modular, modulo. And what we mean is the remainder. So it goes through, it's dividing by 3 and then take the remainder. So at 0, no remainder, so it's going to be 0. At 1, 3 divided by 1. Oh, whoops, other way around. 3 mod. 3 divided by 1 is 0 with remainder of 1, so it's going to equal to 1. At 2, it's going to be remainder of 2. At 3, there's 0 remainder, so it does that again. And 4, 5, 6, it just kind of keeps repeating. So this works fine. The problem is this type of modding, when you do minus, typically, depending on the computer language, it does still work when it gets to the negative space. But I think that I might be wrong, but last time I tried to use this, it used negative number. Like it does negative 1, 2, 3 and repeat, or negative 1, 2, 0, negative 1, 2, as opposed to resetting to 2, 1, 0. So if you do pause mod, you can prevent that. So you can do pause mod, and then you can see pause mod takes, it says returns the integer modulus of x divided by y. Yep, x divided by y. Oh yeah, it is the other way around. So it is correct. I was correct in the beginning. So it would be like this typically. Anyways, but the whole point is that if you use pause mod, you won't worry about negative numbers in GDScript. So you definitely want to use it just in case, because you're setting the expectation. So enemy character state will go from 0, 1, 2, 0, 1, 2. And as I said, enemy character at 0 will put up armor, 1 armor. So it's going to be enemy character add armor 1, and then I'm going to do 2, 3, 4, or 2, 3. How about instead of 1, 2, 3, it'll be 0, 1, 2. You do want a kind of like a vulnerable state. And then it's going to deal 3 damage to the player character. So I'm going to call take damage 3. Same thing, I'm going to copy and paste for the other modes. 2, and then here it'll be 1. And at the end of the action, the enemy wants to, since it played its action, it should move on, end its turn and move on to, what do you call player's turn? Controller, game state, player turn. So now it's at player turn. Now what do we need? We need ways, since it starts with the player's turn, we need a way to end turn. So I'm going to make another button, and this can be a different execution. I'll create a button called end turn. Then I'll put that right here, you know? And then same thing, node, connect the pressed signal to main. If control or game control current state is player's turn, then transition to enemy turn. Button will allow for transition to the enemy turn, and when enemy turn happens, the loop will detect that and immediately execute this and transition back to player turn. I just want to quickly test that the enemy executes its command. So we got player turn. I'm just going to do a bunch of stuff, and I'm going to end turn. Oh, I took 3 damage. No armor here. And then I'm gonna end turn again. This time I should take 2 damage, and then there should show up a 1 armor. 1 armor. And on next turn, it's gonna do 2 armor. Once again, I don't have a reset, so that means it's gonna go to 3 armor. 3 armor. And then I take 1 damage, and then back to 3 damage. It works. Now the next thing, something that you notice here was that the armor doesn't reset properly. And what we want to do here is that logically, I want whoever applied the armor, that armor should disappear at the beginning of their own turn. Beginning of their own turn. So I think this is perfect for here, transition. This is what I would consider transition. Technically, I want to do it on the transition, but I want to do it in the main script because it just kind of simplifies data access. Because if I try to do those logic in here, even though I made all these things, that means I need to pass the player character into the controller, blah, blah, blah. So it complicates it. So I will not do that right now. I'm going to just stay in main script. And That means when the transition happens, this is where the transition happens. In the beginning of enemy turn, we're going to say enemy start turn, right? And then in the beginning of the player's turn, I'm going to execute player characters start turn logic. So that's the beginning of the turn reset. So new function, start turn. So far here, only one thing. Armor gets reset to 0. That's the only thing we have. So that's all that is. So if we play it, it should work. First of all, if I add armor, I end a turn, enemy's gonna do its own thing, and then it's gonna come back to my turn, and it should be reset. So I end turn, armor is gone. I took only 2 damage. It looks like 2 damage because it was 3 minus 1. And if I do it again, they have 1 armor. My 1 attack is not going to do anything. Boom. It doesn't do anything. And then it's going to, when I end turn, it's going to remove this armor, deal 1 damage, and then put 2 armor. So we should see 2 armor here, 2 armor, and I took 1 damage. And turn 3 damage, blah, blah, blah. Cool. One thing you probably notice is that when the enemy has 1 armor, I don't have a card that can get through the armor because all my damage cards do only 1 damage. So if they have armor, like I'm kind of stuck. I'm going to resolve that. Oops, sorry. I'm going to resolve that later. But for now, I'm just going to go with this. Another thing, mana should reset every turn, right? I think so. So I'm going to do that. We're going to put it to, on the start turn, mana should equal 2. Now, I can say 10, hard-code it like this, but what if player gets more mana? What if I make it so that the mana increases every turn? Like at turn 1 is 1 mana, at turn 2 is 2 mana, at turn 2 is 3 mana. It might change over time. So it's going to have a this current mana value, and it's going to have another one called current max mana, or mana cap, I guess. Current mana cap. And then set it to 3. Let's do 3. And then it'll reset to 3. I gotta reset these. Okay, that's what I thought. All right, I went to the character nodes and then I reset their mana amount to a default amount. So there are 3. I'm gonna, let's say, defend and turn. I took 1 damage. I'm gonna attack a lot right now with everything I have, and then I gotta defend. Oof, difficult. Right now is my turn. I'm just gonna attack as much as I can right now. Ooh. Okay. I gotta win right now. Yay, I won! Okay. Cool. Fun. Oh, I keep touching the mic. All right. Fun. That's got it. I got it. All right. Next, there are a few checks I'm not doing here. I'm not doing if the mana is available or not. So for example, right now, I can use as much mana as I want. I can go to negative, which is not what we want. So what we did here, remember, if the card gets clicked, that signal gets all the way bubbled up into deckhand, and then it gets connected to main. And in main script, we have on deckhand hand card activated, and we just simply activate the card. So instead of doing that, we want to verify that there is enough mana. So we're going to first get the cost. So here, what we're going to do here is we're going to get the card and say get cost, which doesn't exist yet. So I'm going to go into this usable card script. So the way I do this is, since I have it typed, I just hold Control and makes it underline. I can click it, and then it takes me to this script. Otherwise, I can just open it on the scripts, obviously. And then I'm going to make a function called get cost, and it simply returns an integer value of the cost of the card. And that's going to be, if you look at the attack card and the defend card again, it has the card itself, underlying card, has the card cost. Grab that card, and if you look at its script, the card's script, it has what's called a card cost. So I'm just going to grab card cost and return that. Right? So that's the script for usable card, and it applies to both defend and attack because they share the script. And once I have that on main, where deck and hand card activate is handled, this will work, right? It's going to be int here. And then card cost will be if card cost is less than equal to current mana, which is player mana, right? Because it's the player's turn. So I'm going to just drag and drop the player. And then it's going to be mana. Then activate. Right? Otherwise, nothing happens. So let's check. I'm going to have a bunch of attack cards. 1, 2, 3. And then nothing should happen. Nothing happens, but the card still disappears. That's a problem. So let's make it so that disappearing of card only happens on activate. If you remember, we got deck and hand logic. I'm going to click on this script. Card activated. I emit it, right? So this is not handling the delete. Then if you go to the hand script under deck and hand, when mouse is clicked, it removes a card. But now, I don't want this, right? I don't want to do this. I just want to simply... Oh, this is going to be a problem, isn't it? Well, the way I remove card is by producing the index. I already removed the card. So remove happens first. And that's the problem. So the way I want to handle this now is instead of removing it, I just simply want to bubble up the card without removing. So basically peek the card and make the top-down logic to command it to disappear. If you look back at deck and hand, on mouse click, you used to remove card in order to get that card. So instead of doing that, I want to just simply get the card. By just getting it from the hand. And then it's going to be current selected card index. And a square bracket, current selected card index. And that will, I think, get that card and it'll bubble it up. We need to be able to remove that card. So I have it so that remove card command is by the index. So we'll make it so that we have another command, func remove card by entity, and then it'll take in a card, and it's going to do hand find card, and that's going to be the index, remove index. So I find the card in the hand, and that's the remove index. And then I'm going to do remove card by index on it. Like that. That should work, I think. All right, so we have ways to remove the card by providing the card entity. Cool, cool, cool. And then this is a hand logic. So deck and hand will receive that card. I'm going to have a function in here that says remove card, and it receives a card, node to D. And then under it, it's going to call hand, remove card by entity, then provide that card and remove it when I want to remove the card. Deck and hand has remove card function, which calls hands remove card by entity function. At this point, I want to test and make sure that the selection logic is still there. So I'm going to play it. And it's not going to remove, but it should still do all the logic. So if I do defend, 1 armor, 1 mana, attack, 1 attack, and I can't use anything anymore. Perfect. And in the main logic, over here, we want to make it so that if the card is successfully activated, we want to remove that from the hand. So we got deck in hand, I think. Yeah, deck in hand, and then we're going to do remove card, and it's going to remove itself. In this way, now it's going to only remove the card if it's activated. Removed, 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 and now it shouldn't remove. Perfect. Okay. Ideally, what we want to do here is that we want to flash the card red or like just like wriggle or make sound so that to indicate that the card could not be used because the mana. But fundamentally, the logic is working. We kind of have a game going right now, right? So have this, can't do it, so I have to end my turn. Attack, end my turn. Defend, end my turn. I'm done. Cool. I love this. It's working. So basically, we can fight the enemy. Enemy can have a turn. And also, I have ways to check mana. There's some restriction there. And then things will just work kind of naturally. Now, 2 things we're missing is game over and victory. But I think that's something we can add. You know what? Let's add this right now. Because I was about to say we can add this later after adding deck. So we can draw from the deck. And we have discard pile and all that stuff. But I think, you know what? I want to put a placeholder for game over and victory, right? So we can actually have the satisfaction of playing the game. So I'm going to make a game over and victory screen. Because it's a separate overlay on top, like a UI over UI. I'm going to make a canvas layer just for it. In the canvas layer, I'm going to create a color rect. And let's make it full so it covers the entire screen. And I'm going to make the color have some sort of alpha value. And then make it like dark. Maybe it'll be kind of like reddish. Okay, this color rect is going to be game over overlay. overlay. And then I'm going to hide this. I'm going to make another one. Color rect. Go to layout. And then anchor preset will be full rect. Once again, this one's going to have a alpha value. And then maybe it can be kind of like greenish, victory overlay. And put a little label. Label's going to say victory, if I know how to spell it, victory with 3 exclamation point. And I'll center. Let's make it so that the layout is anchor, and I'll make it centered. Yeah. I'm going to do the layout mode anchor so it can detect where it needs to be placed. I'm going to put it at the center. And then I'm going to create a new label setting and then click on it, font, and drag and drop my trusty little font down here. That's too small, so I'm going to make it like 64 maybe. And then let's make it, yeah, yellow. That's great. And then I'm going to copy this label and then put it on the game over overlay. Whoops. Copy this label and put it under game over overlay. I'm going to turn this off so it's not confusing. I'm going to say game over. And then, of course, this is going to be something more sinister. Yeah, there you go. Bam. All right. So way I'm thinking, oh, maybe I need to make the overlays a little bit less transparent because I can't really tell. There you go. So what I'm going to do now is I'm going to make it so that it turns on and off, like the visibility, based on if you won or if you lost. So real quick. Oh no, my camera is about to die. Ah, is this working? Okay. Oh, all right. Oh man, syncing this is gonna be pain. Okay, yeah. Game over, victory. So same thing, it's another state. So what we're gonna do here is that under the process, we're gonna make another if statement where if game control current state equals game controller game state victory, then we're gonna make victory visible. And then it's gonna otherwise make that invisible. Once again, this is a simple if then, so technically you could do it like this. Right? Where instead of doing an if statement, you take the actual truth or like the actual conditional statement that is evaluated as true or false and make the value equal to the evaluation. Cool. It's a one-liner. Wow, it's amazing. Doesn't read well to me, in my personal opinion. So I'm just gonna do it this way for now. Like it's not really hurting. It looks kind of nice to have this type of like organization. That way, if I need to do additional work in here for each of these statements, so instead of victory overlay, this will be game over overlay on the state, on the case of game over. Same here. And then this will be true here. And then this will be true here. I guess I want to be able to reset the game, right? I want to restart the game. So I'm going to make an input where I say, when you click R on the keyboard, it resets the game. So first I'm going to check on the project setting if the key R already has a mapping. So I'm going to go over here in the input map on the setting, include the built-in. I'm going to do filter by event and click R, and there's nothing there. So I'm going to create a new one called restart, enter. And you can see restart here. Now I'm going to add a little thing, and then just going to click R, and it leaves me right here. So I'm going to just do this. Then it's a restart. We're still on main script. We're going to come over here and make a new default function called input and say if event is action pressed, and it's going to be restart. Then we're going to reset or restart game, which we didn't implement yet, so I'm going to implement it now. What does it mean to restart this game, right? Function restart game. First thing first, that means the game control the current state to player's turn, right? Player turn. And then we're going to make the character state reset. That is the complicated part. So over here on the game screen, we have player character and enemy character. We could go and do something like, hey, player character HP equals 3, blah, 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 and then determine those values individually. Or we can make a function under the character called reset. 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 So that I can just simply call reset on the character. Right? So if we go back to the main script, I can just simply do player character reset and then enemy character reset. This is where we want to make sure we store the original value. So you see these like default values we have set up. These default values will be different based on the character and based on their status. Because think about this right now. I can't just simply say on the reset, health equals health or whatever. We want the ready to store the initial setup value. Because through the gameplay, these variable values are changing. So instead of having the health, mana being set up during the character creation, we want to make it so that what is being set up is untouched number, like the static number. So the max health, the mana cap, and starting armor, or base armor. Let's call it base armor equals 0. And then the health, mana, and armor is simply assigned on reset. So it's going to look like on reset, health is going to be max health. Mana is going to be mana cap, or current mana cap, which just call it mana cap. Or let's say starting mana, since that could change. Starting mana. Then we can have a separate variable called mana cap. Export var mana cap. Current mana cap. So we have a starting mana, that is to say beginning mana cost, and current mana cap, I made it separately because, as I said before, what if I want to increase this like maximum mana over turn? I'm going to do that. So we got starting mana, so the mana will be starting mana. And then armor is going to be base armor. Cool. Okay. Enemy character, I'm just going to reset everything. Reset everything. Starting mana 3, base armor 0, mana cap 3. All that good stuff. That also means we want to call reset on ready, because that's when the game first starts. So I want these values to be set up based on the character setup. I think this should work. Hopefully that was not too difficult to follow, whatever I just did. So now we have ways to reset the game. I'm going to start the game. I'm going to just press R. Okay. All right. So I am able to reset. Notice the reset didn't refresh the hand. So I think I kind of want to do that. So on main script again, when restart is triggered, I restart the game. And restart game function has a player reset for both. Makes the current state to player. I also want to reset deck and hand. Whoops. So I'm going to make a new line, drag and drop deck and hand, and then I'm going to say reset. So I got to now go into deck and hand script and make a function called reset, which basically I want to empty the hand here. So I'm just going to do this hand dot empty. And I got to implement that. So I'm going to go into deck and hand, get the script for hand, and create a function called empty hand. Remove hand, empty hand, doesn't matter. I don't want it floating. So I'm going to actually free the cards off of the queue. That is to say, free it from the memory so that it no longer is in the memory. So I'm going to go through each of the cards in the hand for card in hand. I'm going to card queue free, and it's going to delete it. Which reminds me, when I delete the card after activating, I forgot to free them from the memory. So actually we have a memory leak. We delete the card as a graphical representation, but we don't free it from the memory. So those cards that I've created throughout the gameplay is still floating around. So we need to make sure we call free whenever we delete the card. And we wouldn't do it here because card being deleted from the hand doesn't mean it's deleted from the, it should be deleted from the game, because the card may be in the deck, it may be in discard pile. So we want to make sure we do that here on the main, and we want to do it when the card is activated, which is when it's getting clicked and then activate. So here's activate. We're removing the card, and then after the card is removed, we gotta queue free to remove it from the memory. And we can test that later. So we gotta make sure we do this. All right, we have reset, deck can. One thing I noticed when I was like just messing around earlier to test the restart, if I just end turn, at this point I should have seen game over already, but I didn't. We made it so that the overlay happens, but we didn't make it so that it transitioned to the overlay. The game loop will check if, you know, game screen player character dot HP is less than or equal to 0, then game control transition to game state called game over, and then elif, and I'm doing elif here instead of another line of if, because if the player HP is less than 0, it's game over even if enemy is also 0. Like if you arrive at that point somehow together with the enemy, it should still be game over as opposed to victory. Like if you barely win, then it should be a loss. So we got victory here. Cool. I think we got everything we need. Just to be sure, I'm going to open a debugger. Here, I'll show you. If you go to debugger and go to monitors and then look at objects, orphaned nodes. We want it so that, oh, HP doesn't exist. What do we call it? Health. Okay, sorry. So this should be .health. Restart the game. Okay, so if I do this, and then I activate these cards, and turn, activate these cards, and turn, activate, and turn, we want to make sure that the debugger, the monitor, does not have any orphan nodes, and it doesn't, and that's beautiful. Another thing, I'm just going to end turn, game over, reset. Oh, hand.empty doesn't work. That's because I didn't implement it. That's not the name. All right, I'm going to go back to the hand, deck and hand script, empty hand, not hand. All right, here we go. We want to reset the current selected card for sure. So we're going to say current selected card will equal to -1. I guess we should do this first in case there's some weird complication. I think if I'm correct, the touched will also be reset, I believe. If I queue, because queue free means it's just going to remove it altogether from all pointer. Let me just make a little print here so I can get a little breakpoint here so I can hover over all these variables to see what their state is. Okay, I'm going to restart the game. I'm going to add a bunch of hands and end turn until I get a game over. And I'm going to R, and it breaks right here. So I can see hand is full, touched is not, current state is -1. Huh. I see. Attempt to call function unhighlight and base previously freed on null instance. So it seems like I thought, interesting. So this is my mistake. I thought when you free an object, the Godot logic will go through all the places where these objects are connected to and then null it out. And it does null it out, but then the kind of placeholder for that pointer still exists, it seems like. So that means when we're emptying the hand, we want to make sure the hand is an actually empty array. And for good measure, we also want to make the touched to be empty array as well. Again, we have all these, interact, and turn R. Perfect. Okay, now let's try to win. We're gonna attack. We're gonna, oh, we can't attack. We gotta defend. And then we're gonna attack. We're gonna get some defense going. And then we're gonna attack again. This is our game. 2, 3. And then last one, attack. Victory! And then reset. We're back. All right, we have a functioning game, minus the sound effect, minus the exciting GUI effect, and then all the animations. But we have the base game. There's AI logic, card works, and then I can always add more cards. There's some basic loops, game over and victory. So I think this is a great stopping point. On the next episode, I'm going to work on deck and discard. I'll try to be a little bit more ready. I'm going to think about it a little bit over the time of break. But yeah, this is what we have. Let me know if you have any feedback. If you want anything more, less, then let me know. Because I'm ultimately doing this for you guys. And I want to be as helpful and resourceful as possible. As always, this code will be available as part of the branch in this repository, which I'll link in the description. So go check it out. You don't have to even follow this through. You can just look at the code directly. And I'm going to do that for every episode. And then at the end of the day, I'm going to make another game that's based off of this tutorial. I'm going to make that available in Patreon, along with like the source code in Patreon, along with the game itself, the game Steam code or whatever, when I release it. So look forward to that. I'll see you all later. Bye.